So I am in my IntelliJ. Let's start solving this problem here. Okay, so here we'll go with the same approach. We will solve our using this algorithm. We'll start solving our problem, and let me exactly take the same method name given here in lead code. I will mark it as private static and final here. So, but before that, I mean, let's solve this problem using our helper function that we have done before, where we are just calculating based on this formula, right? And then finally, in our main function, we will use this formula for maximum calculation for the first two indices, I mean, excluding the last one, and for the sub array, for excluding the first element and just using the remaining elements. So first of all, let's write this helper function first. Okay, so I will call it as rob1. Okay. And so let's do with a very base case that, as we discussed, that if we are only given like one array, one element, one house only, we simply return the value which was there, right? So this would our base condition, that if nums.length is equal to 1, then simply return it. Now let's create our DP array now. It would be nums.length. Okay. And DP of 0 would be nums of 0, right? We are just putting this DP, because and DP1 and DP0 and DP1 are very straightforward. DP0 is the number itself, and DP1 is the max of these two elements, right? So we'll just use that to fill our base conditions here. So it would be math.max of nums1, because we haven't calculated DP1 yet, and DP of 0. We can write nums of 0 or DP of 0, both are same. I just use DP just follow the bottom up paradigm, that we are reusing the results that we have already calculated before. That's why I use DP0, but you can also use nums of 0 because both are same. Now let's go with the remaining elements starting from 2, and we move to the last element, which is our final solution. And here we simply use this formula, right? That nums of I plus dp I minus 2, max of these two values, or dp I minus 1, which means that if we are robbing this house, then exclude this house, and then whatever the dp was there before this index. Or if you are not planning to rob this house, then whatever the dp was there till this point. So just write this again here. Dp is of I is equal to math.max, our Java utility here, and I will just use the same formula, nums of I plus dp of I minus 2, right? If we are choosing the house right now, or we don't choose this house, then we have to choose the dp of the previous house. So that's all about the formula here. And finally, our last dp2 will be the result of this solution if we are just choosing the house robber original solution here. So it would be return dp of nums dot length minus 1. Okay, remove some extra spaces here, and that's it. Now our main formula here. Now we have got this helper function here for original house rubber problem. Now let's solve for house rubber 2, where we take the maximum of these two. So here, okay, again, I will just use the same base condition here, just for, I don't want to do any further call if nums of, if we are given only like one house, so we simply return it here. Now we have to return the math of max of row1, right? But here we are going to pass two sub-arrays, right? First, in the first row1, we will pass. So in Java, we can use a utility function from arrays, which is copy of range, right? So from original, from, and to. This is a very useful function, and it's quite efficient as well because it's from Java API. So I will use copy of range. I will take nums 0, starting from 0. So here in the first case, we are going to exclude the last element, the last index here. Okay, so because this nums dot length minus 1, because here in copy of range 0 is inclusive, and this last number, this last is exclusive, which means that this will not be included. So it means that we are, and this is actually exactly same as from here to here. We are excluding this, the last element here. Okay, and the second case was that for this row 1 and minus 1, which means that we are going to exclude this first element. So we'll again copy the same method, but we'll change our from and to parameters here. So this is first. Okay, and let me write it down in second line to make it easier to view. And it would be from just 1, right? And because this last is exclusive, so it would be nums.length. So it would be from here to here, right? Okay, so that's all about it. And let's run this for the sample examples, for all the examples that we have been given. So just take the same example, 2, 3, 2. Okay, let me run this now. Okay, the answer is correct here, 3. Now let's copy this and run it in lead code. So I'll copy this part first. Okay, we are here. Let me create some extra space. And also we have to copy our helper function, this one. So I'll just take from here to here. And just submit it. Yeah, so yeah, it's quite efficient as we can see. So let's quickly calculate the time and space complexity. So the time complexity here would be, because we are only using one for loop here, so it would be just O of n. And the space complexity would be, because we are iterating it 2 times, right? We are creating DP array 2 times for first for this particular sub array and then the next array. So it would be O of n square. Yeah, so this was all about the house rubber 2 problem. Guys, today we have solved total 25 problems in this series. So watch out for the next video. What are the next steps that I have planned.